Dalton's law of partial pressure states that the total pressure in a container is the sum of the pressure of each of the gases that they would exert if they were alone in the container. In other words, our total pressure would equal the pressure of gas 1 plus the pressure of gas 2 plus the pressure of gas 3, etc. So again, our total pressure of our gases would be equal to the pressure of gas 1 plus the pressure of gas 2. Water evaporates, and when the water evaporates, the vapor has a pressure. So gases are often collected over water, and so the vapor pressure of water must be subtracted from the total pressure. Well, let's look at an example problem of Dalton's partial pressure. A sample of natural gas contains 8.24 moles of CH4, that's methane, 0.421 moles of C2H6, which is ethane, and 0.116 moles of C3H8, which is propane. If the total pressure of the gases is 1.37 atmospheres, what is the partial pressure of propane, C3H8? We will begin with our pressure of our propane being 0.116. This is stated in our problem. We will divide that by the total pressure of each of the three gases. The 8.24 of our methane, 0.421 moles of ethane, and 0.166 moles of propane. We get 0.0132 for our propane, and we're going to take this right here, which is in atmospheres, we're going to multiply this times our total pressure stated in our problem, and our partial pressure for propane would be 0.0181 atmospheres. Well, let's look at one final example. Oxygen from the decomposition of potassium chlorate was collected by water displacement. The barometric pressure and temperature during this experiment were 731 millimeters of mercury and 20 degrees Celsius. What is the partial pressure of oxygen collected? Well, we are told that our total pressure was 731 millimeters of mercury. We were also given water displacement. Therefore, that water vapor pressure must be subtracted. So we have to calculate our pressure of water. Notice that we are at a temperature of 20 degrees Celsius. So we need to get this number from our table. Let's look at our next slide and see where we got this number from. So the problem told us that we were at 20 degrees Celsius. We need to look at the pressure of water at 20 degrees Celsius. In this chart, we see that the water vapor pressure at 20 degrees Celsius is 17.54. So now we see that our pressure of water was 17.5. We got that from our table, and we just looked up the temperature of 20 degrees Celsius and found the vapor pressure. Our total pressure is a combination of the pressure of oxygen plus the pressure of water. Now, to find our pressure of oxygen, we will take our total pressure minus our pressure of water. Our total pressure was given to us in the problem as 731. We found our pressure of water by looking up the temperature and pressure from our chart. We did a subtraction, and so our pressure of oxygen would be 713.5 millimeters of mercury.